Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, ways. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello, good evening, everyone. So I hope I am properly audible and visible to all of you present here. And I would request all of you to kindly do a +1 in the chat box so that I could get to know your names, those who have joined with me presently. And then we can very quickly start our session. Okay, so we have 1 minute remaining from 9 p.m. We'll start our session strictly at 9 p.m. Okay, so those who are with me, kindly do a +1 in the chat box. This will help me to get to know your names, and at the same time, this will also help us to keep the session interactive as possible. Okay. So yeah, hello, Dev Bhatt, how are you? So before I begin, let me give you all a small introduction about the series. And before that, just give me a confirmation that I'm properly audible and visible. Okay. Thank you very much, Pushpendra. Hmm. So let me share my screen as well, and then we will start. So I see quite a lot of audiences here with me presently. Okay, thank you, Pushpendra. Okay, so let me share my screen, and then I will give you an introduction about this series, and then we can start with the problems. Okay, so yeah. So before I begin, let me just give a small introduction about this present series that we are having. Okay, so yeah. So this particular series is called Practice Session for SDE Interviews. In this particular series, what I'm doing is that taking up important topics and very important problems from those topics every week and discussing them one or two topics every week. Okay. So the idea of this series is to deliver you a good quality content on a regular basis. Okay. We also have a course called Complete Interview Preparation as well. The link of which you will find in the description of this video. So basically, in that course, that is an extremely well-structured course if you're preparing for your interviews. Okay, so I would definitely recommend you all to check out that course. Okay, so yeah, the name of the course is Complete Interview Preparation. So in short form, we call it the CIP course, and it's a very good course. Okay, it's extremely well structured and to the point. Okay, so how many of you are in your second years or in your third years who would be appearing for your upcoming internships or placements interview preparations? Okay. Can you please do a +1 in the chat box? Hello, Pushpendra. You're in your which year of your college? Hello, David. Similarly, I would request all of you all to kindly do a +1 in the chat box. That would most certainly be very helpful for me. Okay, so yeah. So this week we will be studying majorly dynamic programming, and we started dynamic programming 2 weeks back. So since it's a very big topic, we are covering, we are taking a lot of time with it. But next week we will be going on with graphs. Okay, so yeah. So this particular topic, dynamic programming, is basically we did quite a lot of problem. If you would watch the recordings of the previous sessions, that would be helpful. But today we will be dealing with a very important problem called 01 knapsack. Okay, so I would request all of you all to kindly stay with me. The session won't be very long. It will be around 30 to 35 minutes. I will be only discussing knapsack problem and a subset problem. Okay, so there is another problem called count subset, which I've already discussed in my previous session. So this is basically a continuation of that particular problem, because if you are able to understand this, then you will be easily be able to understand 01 knapsack. Okay, so yeah, let us continue then. And before I move on, let me okay, Devbhat, you are in your third year. That's great, Devbhat. All the best for your preparation. Can we please start up with the problems? Yes, Devbhat. Yes, sure. What I do, I'm in BSc 6th semester. Okay, Ganesh, then that is also good. If you're preparing for your interviews, in that case, DSC should be very important, and you can definitely check out these two courses that we have: self-paced course. Okay, so DSC is self-paced course and the complete interview preparation course. Okay, so these two are the flagship courses at Geeks for Geeks that are very sufficient for your preparation. Okay, and before I move on, let me give you my introduction. My name is Gaurav Kumar Shaw, and I am presently in my third year at IIT Kharagpur. Okay, in fact, my third year is about to end in a few weeks' time, and then the summer vacations will be starting, and I will be going at CureFit to do my SDE internship. Okay, so this was about me. So let's move on with the concept of knapsack. Okay, so the problem statement. First, let us look into the problem statement. So basically, let's say there is a thief who wants to rob a particular store, and he has a bag of capacity W. Okay, so he has a bag of capacity W. And he went to a store. In that store, there are n items, and its weight and the weight of each item is given by WT array. Okay, so we have an array which basically gives the weight of all the n items. Okay, so basically, and every item also has a value associated with it. For example, let's say there is a item A. It has a weight equal to, let's say, 2 kg and a value equal to 20. Okay, so we have two arrays: a weight array and a value array for every items. Okay, now the thing is that he can either include an item in its knapsack or exclude it. Okay, so you have two options. So he can either include or exclude. Okay, one full item. Okay, so this is different from the fractional abstract problem, because in that case you can have fraction of a particular item, but here you have only two choices: you can either include or you can either exclude. Hence we call it 01 abstract. So now we have to find the maximum value of items that a thief can steal. So find the maximum value of the items that the thief can steal. Okay, so this is the problem statement. Now, the first question that I would like to ask you all, that why a greedy strategy won't work. Okay, because we are doing a session in dynamic programming, it means that we have to apply the concept of DP. So I'm asking why a greedy strategy won't work. Can you give me a case that will help me understand that why a greedy strategy will not work? Okay. So anyone? Ganesh, since no companies are coming to your college, you can definitely try to do off-campus internship by mailing and reaching out to potential recruiters over platforms like LinkedIn. Okay, so that will certainly be helpful. In fractional knapsack, we maintain ratio value by weight, and it's kind of greedy one. Yes, fractional knapsack is greedy one, but once we move towards 01 knapsack, greedy strategy won't be working, and we have to deal with dynamic programming. Okay, so yeah. Okay, so let me give you an example to show that why a greedy strategy won't work. Okay, so let's say that, okay, so let's say that I have three items and the weight array is 3, 2, and 5, and the value array is let's say 30, 40, and 60, and I have a weight is equal to hmm, hmm. Okay, so this is a weight array, and I have a knapsack. My knapsack weight is 6. Okay, so since if I let's say I go by greedy solution, in that case I will try to see that the value 60 is basically giving you. I will try to take the value 60, and the corresponding weight will be 5. So I will put 5 comma 60. So now my remaining space is equal to 1 kg. Okay, but I see that I cannot put any more items because none of the items are less than or equal to 1 kg. Okay, so in this case, what I can do here is that this is one of the possible way I can get a greedy solution. But let's say I, instead of taking this item, I take these two items. The sum of 3 plus 2 will be equal to 5, which is definitely can fit in 6, and the value will become 70. So it means that I discarded the value. I discarded a particular item having the highest value and took two lesser values, such that the weight also got maintained. Okay. So in this case, yeah. So thing here is that the distribution is not uniform. Okay, distribution is not uniform. Why not uniform? Because in fractional knapsack we were maintaining a ratio. Okay, so we had the liberty to choose a fraction, but in this case we can either choose an item or not choose an item. If we greedily choose an item with higher value, we may miss on potential items which may come later, having lesser value, but having much higher weight. Okay, so why dynamics is important in this question. Okay, so yeah, that's why greedy will not work. Okay, so I hope everyone understood it, that why greedy is not working here. So in this case, we have to devise a dynamic programming with solution. Okay, so greedy fails. Okay, so we have to devise a dynamic programming based solution. Okay, okay. So let us move to a dynamic programming based solution then. So the first and the most important step in maintaining a dynamic programming based solution is to write a recurrence relation. Okay. So let me write a function called int knapsack. Okay. So this is I have a weight array, I have a value array, and I have n, I have w. Okay. So this is the content, basically the information that I have been provided with. Okay. Now what I can do here is that I have to declare a function. So these are three values. I will declare a function f. Okay. So let me write that function first, and then we will proceed with the implementation of the function. Okay. So I'm trying to write a recurrence relation. So let's see, int f. This particular will take a vector wt, a vector value vector, and index vector, the present index in which I am standing, the int w, the capacity of the knapsack. Okay. Now what else? Now what should be my strategy? Okay, so let us look into it. So for every item, I've got two options. Okay, since the greedy strategy is failing, it means that we cannot make a bias and choose any particular item. We have to make sure that we are particularly taking care of all possible ways I can pick up the items such that it fits into my knapsack. Ultimate goal is to fix it into my knapsack such that the value is maximum. So what I can do, I will try out all possible combinations such that my knapsack is filled, and of all the possible combinations such that the knapsack is filled, I will take that combination which is giving me the maximum value. So this is a two-step process. So the first step would be to it may happen that I'm not taking that particular item. Okay, so if I'm not taking, in that case, I'm adding 0 to my knapsack, 0 to my value, and I'm recursively calling for that function. But this time, the weight array is same, the value array is same, the index array would move by 1 because I'm starting with the last index n. Okay, initially I'm starting with n. Okay, after that, my w value will again remain same. So this is the case in which we are not taking. But let's say I am trying to take a particular item. Okay, so in taken, now when can I take an item? So there has to be a condition when I can take an item. So I can only take an item if the weight of that particular item is less than or equal to w. Okay, so weight of index is less than or equal to w. It means that if I'm taking that item, I can fix it into my weight. If it is possible, in that case, what will I do? I will write a value called taken. Taken is equal to uh, hmm, is equal to value of index, the particular value which I took, and then I will recursively call for again the same thing. Okay, but in this case, what will happen? The value of w will also decrease because my knapsack is now occupied with this value. So w minus value of index. Okay, so this is what will happen here. After that, what we will do here is that, so this part is done. Now what we will do, we will return. Okay, we will return maximum of the not taken and the taken. Okay, so this is the idea. So now the question arises: what is the time complexity and what is the space complexity of this approach? Okay, first tell me, is this brute force recursion or this is an optimized dynamic programming version? Tell me first. What do you think it is? Hello Devbhat, hello Ganesh, hello Pushpendra. Okay, so let me tell it. Let me just tell this to you all. The time complexity of this problem will be exponential. Okay, because you have two possible combinations, so it will be exponential in this case. Okay, and since we are having a lot of recursion trees, this will definitely not work. The computational it will be very expensive. So we have to optimize this with a DP table. Okay, so what can we do here? So let's say we have a DP table here. Hmm. Okay, so what can we basically do here is that. So yeah, but before I move on to the DP table, there is something as a base case. Okay, the base case would be that if index is equal to 0, it means that I have reached the last possible index. Now I will check if the item present in the last possible index is less than or equal to w or not. If it is, in that case, I will just return value of 0. Okay, why I will do value of 0? Because I'm taking that item and it will just add it to it. Else I will return 0. Okay. So in order to optimize this, we have to put a DP table. So what are the states of DP? The DP table will have two particular states. The first will be the index and the second will be the weight. Okay. So first we will be having an index and then we will be having a weight plus 1. Okay, because these are the two changing parameters. We are moving the indexes and we are filling up with our apps. Okay. So every time we are moving down into this recursion, what we will basically do here is that in this part, hmm, instead of just returning this, I will return dp of index comma w is equal to this particular value. So once I'm getting a maximum value for any particular recursion, I will store it into my dp table and I will do a same check and I will do a check before I move on to the recursion part. Okay. So I will do a check here that if dp of index and dp of w is not equal to minus 1, in that case you can just return dp of index and w. Okay, correct. So this is how we are trying to solve this problem. And there is one small mistake in this code. Can anyone identify a small mistake in this code? Yes, we are initializing the DP based on, we see that all the parameters are changing. Based on that, we will declare a DP. We initialize a DP with value minus 1. Exactly, there, but you're correct. So therefore, there is small mistake in this problem. Can in this code that I just wrote, can you just identify that mistake? Yeah. Okay. So let me just tell you the mistake that it is. So I have declared a variable called. So if you look into it, I have declared a variable called taken. So this will basically become int min. Okay. I want to declare it with a less value because I am taking a maximum of these two particular variables, not in taken and not taken. Okay. So now taken will basically become the value of this. Okay. And if in fact basically what happens, let's say we do not come into this value. If we are coming into this if statement, then only the value taken will be updated. Otherwise, not. So if we are not coming into this value, then what will happen? DP of NW will be max of not and taken. Okay. So this is how it will work. Okay. Yeah. Okay, Dave, but I just told it. No worries. Yeah, we basically return DP of index and wet, but basically the thing is that I'm storing the maximum value of not taken and not taken into the DP table, and then returning that same value. Okay, the syntax basically means that. Okay, so in fact, yeah. So now, Dev, but you can tell me the space and time complexity of this problem. What do you think will be the space and time complexity? So let me tell you the time and space complexity for this particular question. So since we've already optimized it, the time complexity will be something like this. So time complex. So we have two particular DP states. Okay. So we have two particular DP states. Let me see that. So so our DP states are N and W. N is basically the index, and D is basically the current weight of the knapsack. Okay. So my time complexity will become big O of N into W. Okay. And my space complexity will become big O of N into W plus a recursion stack space of O of N because we have N items. Okay. Okay. So this is basically the recursion stack space. So can anyone tell me how can we get rid of this recursion stack space? They've got. Can you tell me how can we get rid of this recursion stack space? Okay, yeah. So basically, Abdul Rahman, yes, exactly. We will be trying to write a tabulation form of approach to solve this question, so that yeah, yeah. So instead of the recursion, so the idea of recursion is basically to implement. So the idea of that particular recursion stack space will be implementing a tabular approach and not a recursion approach. Okay. So let me give you a tabulation code. So this is how a tabulation code will work. So we will be storing up all the values of the tabulation in a 2D DP table. Okay. So let's see. So what we will do initially, I declare a DP table of size so n into w. So this is n. So 0, 1, 2, 3 up to let's say and 0, 1, 2, 3. Wait, okay. So what we are initially doing is that n. Okay, so let me just keep this as n minus 1. So this is of size n and this is of size w plus 1. Okay. So initially what we are doing, we are starting with wt is equal to 0. So we will start with for I is equal to wt 0, wt of 0 and I less than equal to w and I plus plus and I plus plus. Okay. Hmm. Now what we will do basically is that dp of 0, dp of I is equal to value of 0. Okay. Hmm. So why we are doing this? DP of 0 basically means this particular table. Okay. So this particular means that and I is basically this particular weights. Okay, is equal to the value of 0. So let's say it means that why we are putting value of 0 here. Can anyone tell me? So I is basically the weight of 0. So weight of 0 is the weight of the first item, and the weight of the, let's say if I'm picking up the weight of the first item, then dp of 0 comma I is equal, let's say the weight of the first item is 2. So dp of 0 comma 2. So 2 is basically the weight. So I will put a value of 0. If I'm picking up the first item, in that case, it means that I will correspondingly mark it as value of 0, the value which I have obtained here. So we are filling up the values in the 2D table. Okay, we are filling up the values in the 2D table that we will accumulate. So this particular value will give me that I have basically filled up my value w, and then for considering all the items together. Okay, so this is how things will be. So let me write the tabulation code for the next. So can I please have a plus one in the chat box if you have understood the this particular loop is basically for the base condition. Okay. Yes, exactly. Therefore, tabulating the memoir solution is what is important here. Okay. Okay. Yeah. So let me write the tabularized form of the solution now. The steps that basically help me fill this tabulation, fill this DP table. Okay. Okay. So basically, let's say for int index is equal to 1 and index is less than int I plus plus. Okay, index plus plus. Okay. So now now int cap is equal to 0. Int cap is equal to 0. Cap is less than equal to w and cap plus plus. Okay. Now int not taken. int not taken. Okay, so not taken will be equal to 0 plus 0 plus dp of int minus 1 cap, dp of int minus 1 and cap, dp of int minus 1 cap. Okay, and int taken. Okay, so will be int min. Okay, now if wt of int, if wt of int is less than equal to cap. Okay, so if it is less than equal to cap, this is basically the condition in which the base case condition. Okay, so taken will be equal to the value which I have presently in. This is basically the condition in which you are taking it. Okay, so taken plus dp of int minus 1, the previous value which you put, and then cap minus w of int. Okay, this is the idea, and then we will just put the values in the dp table, max of this taken and not taken. Okay, so after we run these two loops, we are done with our we have just filled up our solution. So can anyone tell me what will be the answer to this question? Okay, yes, I'm repeating the base case, but can anyone tell me once we have filled up the DP table, what do you think will be the answer? Okay, which part of the DP table will give you the answer? Okay, so basically once I have filled up my DP table, the answer will be DP of n minus 1. So DP of n minus 1 and W. Why? It means that I have taken all the items into consideration, and I'm particularly filled an AppSet. So whatever value will be stored in this particular cell will be my answer. Okay. So the base cases. Okay, so let's come to the base case since Devdutt was asking. So Devdutt, yeah, this is for you. So basically, what is happening in base cases is that we are starting with int I equal to w t of 0. Okay, so what is wt of 0? Okay, so let's say the value of the very first item is equal to, let's say, 2 kgs. Okay, so what will happen here? So dp of 0 comma 2, it means that you took the first value. dp of 0 is basically n is the first item, and wt of 0, you took that particular value, 2 kilo. So the value and let's say the value is 10 rupees. So what you will do here is that dp of 0 comma 2, you will put the value 10 here. Okay, you will put the value 10 here because you have only taken this value. Now I will become 3. Okay, now dp of 0 comma 3 will also be become value value equal to 10. Okay, why value equal to 10? Because it means that you are only considering the first item. Okay, in this loop you are only considering the very first item that you have. Okay, so in this case you will just fill up the value 10. Okay, and initially you are filling up this all the value with 0. So it means that if you are taking the first item only, the value will be 10. If you are taking only the first item, the value will be 10. Okay, so this is the base condition that we are talking about. Okay, so I must be less than equal to W. Okay, it may happen that I is basically greater than W. In that case, this for loop will not run itself. Okay, so in that case, we can say that so the base condition will not be satisfied for this case. So all the values will be 0. Okay, so this is the item. The base condition says that what happens if you just take the first item together. Okay, I hope everyone understood it. So I hope you understood the base case condition, Devdutt. Yeah, dp of n will store the answer. Dp of n minus 1 actually, because for considering the items we are making it taking into consideration as zero based indexing and not one based indexing. Okay. So I hope everyone understood the zero one abstract. So yeah. So if you have any doubts, I would recommend you all to kindly do a plus one in the chat or just tell me the doubt. Okay. So yeah. So before I wrap up this session, let me tell you that we have a course called Complete Interview Preparation. Hello Sumit, how are you? That particular course is there on the GFG platform, and in case if you are preparing for your interviews, you can definitely check that course out. It's an extremely well structured course for your interview preparation. Hello Sumit, how are you? Do you have any question? You can ask in the chat box. Okay, so yeah, we will be continuing with this session next week, and next week we will be dealing with problems and graph. This particular session is practice session for SDE interviews, in which we are taking just important problems from various topics, okay, and then trying to solve those in a live session of 30 to 40, 40 to 40, 50 minutes max. Okay, so this is about this particular session. I hope everyone enjoyed this particular session and got to learn this important concept, because this is an extremely important basic concept which is being applied to solving various questions. Okay. Hmm. Okay, Sumit. Yes, you can tell your question. I was just giving a general information. Live classes for DS and Python. Okay, I don't think so. In fact, if you can check out the GFG platform for itself, or I will just inform this. I'm not sure exactly if there is. You can check out the comments later on. Someone from GeeksforGeeks team will definitely inform you there. Okay, or you can check out our website and got to know our live classes as well. Okay, but I would recommend you to do DSA in C++ because C++ is extremely fast language and it will help you learn a lot of implementations as well. Okay, Python is an extremely slow language, so that is the reason I'm recommending you to do C++, or in fact Java works well too. Okay, so that is about this particular session. So let's I have written up the code of the tabulation solution on this particular on the whiteboard itself. You can definitely go and check out the editorial code at Geeks4Geeks. That code will be exactly the same, and you can try to submit that and solve it on your own. Okay, because in that case you will basically get to know the how to apply the concept and understanding in solving the question. Okay, I hope this answers the questions to everyone. So see you all in the next session. That would be next week. Okay, bye bye.